All right, guys, I decided to do a quick little video. Maybe it's not gonna be quick because there's gonna be a couple edits here, but when I design something, why do sometimes I choose a laser and why sometimes do I choose the mill? And there's some misconceptions out there in the industry that I've heard other makers talk about, that a laser is easy, the mill is more difficult. At the end of the day, I press a button. We all press a button on the mill, unless you're using a Bridgeport and you're hand cranking stuff, which there's not many of those guys out there left. But especially if you're doing intricate designs, you're designing in CAD and you're exporting to a mill or a laser. And then at the end of that, for the most part, you're pressing a button. So I'll show you what goes into it and why I choose which, pros and cons of both, so you can see how it works. So here's a design that a customer has asked me to put on an item for them. And when I get designs like this, the first thing that I think about right off the bat is the points. So you can see in this R, it's a B and an R combo in this logo, but you can see the sharp points everywhere, right? And we all know that an end mill is round. So you can use a very, very, very small end mill to get into that little corner of that sharp point up there, but it's still gonna be round because an end mill is round. If I use a laser, I can get to a point. So this is a type of decision that I need to make or with a customer to determine, hey, are you okay with a slightly rounded point, or does it have to be precise and sharp and lasered? So here's the rendering of that in CAD. And as you can see here, as I move this around and I zoom in, I mean, that's a sharp point right there. So if I were to mill this, and if that was the option that I was going to decide to do, what I would do is go in here and fillet that little corner, right? So I'll select that corner. Whoops, I selected too much. I want to select the corner. Bad selection. Let's go down here so I can select this corner here. Yeah. Select this corner right here, and then I'm just going to drag it out, and I have in millimeters here. Let's switch to inches, just so I talk in inches usually. But here's that fillet. I want to edit it. And let's clear that. And let's clear that. And let's select it again. And then I'm going to move it out. So if I use a 1/16 inch end mill, which is usually that or 1/32 is the smallest I'll go, I have to do half that diameter to be able to make that end mill go into that area. So 0.0625 would be a 1/16 end mill. So half that, I'll say 0.035. If I do 0.035, hit OK. That rounded edge right there, my end mill can cut all of that. Now, if I'm doing an inlay, it has to be precise because I'm gonna have to cut a piece to fit in there. Same issue. But if I'm doing paint fill, I can make that pretty much whatever I want, and I'm dropping paint in there. Not a big deal. So if I zoom out though, you can see that that's not a pointy edge anymore, it's rounded, but in some instances, it doesn't take much away from what you're trying to achieve in terms of the overall logo. You might not even notice it, but that's a decision that has to be made in the process of designing an item. All right, so here's the CAD operation where in this area here, we're gonna ramp down with the 1/16 inch end mill. And then as we get into this area over here, which you can see, that's where the end mill, right in here, is gonna roll around this area here nicely, won't break because it's not a sharp corner. It'll get all of this because it's not a sharp corner, and it's gonna work, right? So no issues right there. Our end mill will fit in that area because I made that adjustment. You'll notice up in this top corner where I did not make the adjustment, we're just not getting in there all the way. So this corner is going to end up getting rounded off. So if I were to simulate this in CAD, you would see this sharp corner get rounded. And so here's the simulation there. Essentially a 1/16 inch end mill. The green represents the area that's actually going to be cut. You can see how much of that point gets removed, and that's a very small end mill. I could come in here with a 132-inch end mill, and maybe half of that material that's left, maybe about right here, would get cut, because we're going half the size. And then there's even smaller end mills. But once you're getting into something like, if this is a stainless steel ball marker, using 132-inch end mills, you're gonna break a lot of end mills to achieve corners that are still rounded, just rounded more or less, I should say. So that's the whole process behind milling and why someone might choose a mill versus a laser. So let's talk laser next. Well, before I talk laser, let's talk mill. So what will happen is I would download that CAD onto this jump drive. I would plug it into my Haas right here. All right, and it's not on right now, sorry. I would just then adjust and find a certain point using the probe, which is this tool right here. The probe would touch off the area, boom, boom, and then the top. So I get my X, my Y, my Z. It would know then where that item is in relationship to this piece of stock, and it would start milling it. So my 1/16 end mill is right back here, which you can see is very small and very delicate. 132 is right here, which is even more delicate. You can barely probably see it there. But you would mill that out and it would leave that cavity. But at the end of the day, after I put my jump drive into the mill, I would program just that probe to work to touch off those three areas. And then the computer built inside CAD and built within the mill, the cam, would know what to do. So all I would do then at that point is hit cycle start, and I would walk away, and I would come back when it's done, and that thing's milled. So when guys say lasering is, not as much as milling, let me explain why I think that that's inaccurate. Let's talk about lasering. That last program I showed you, the CAD program, is Fusion 360. When I do lasering and artwork in general, I use something called V-carve. So here's V-carve right now. I have a rendering of my logo inside of an octagon, and this is actually a marker that I've made before where this is an inlay. So I have the drawing, I upload it in here, and what I'm going to do now is I need to make sure from a size perspective that it's relatively close to what I need it to be. And what I mean relatively close, what that means is the laser is it's certainly not as accurate from a sizing perspective as the mill would be. So with the laser, there's a lot more of, I need to make this fit, I need to eyeball it. There's some more hands-on. I don't have a probe on my laser where I can find exactly where something's gonna lay. So for example, if I wanted to, on this crayon right here, laser my logo on the end right here, right? I can't just simply probe each side of this with the laser and find the dead center. I have to eyeball it. Sure, there's a little light that will shine on there and kind of show me where that engraving is going to be, but it will never, ever, ever be exact on a laser because there's no probe and there's no way to find the exact center of this circle on the end. So I have to eyeball it. And if you get it wrong, that piece is garbage. So that's kind of one of the cons of using the laser. So I would take this drawing, throw it on a jump drive, and then bring it over to the laser machine, and I'll show you how that works. One more thing to consider with the laser, it's so precise, it's a beam of light. It's not like an end mill where there's a circle that can't get into certain corners. The laser can. It'll get into those corners, it'll carve everything out, and that's where the precision of the laser comes in. And that's why I use it in instances where a customer wants sharp corners. I want a sharp corner in a design. I don't want to lose any of the intricacy of the design. That's when the laser is used, in my opinion, and it does a better job when it comes to intricacy. But let's talk about what that means in terms of not having a probe like the mill does. So to give you an example, on the mill right now, I should say on the laser, I have my depth marker. And yes, the depth marker is laser engraved. That's by $3, for $3. And the reason for it is, look at all the intricacy in there. I would never be able to fit a mill in many of those areas. And there's certainly sharp corners in here as well. Now, here's another reason why maybe the mill might be better. Speed. You would think that a laser would be faster. Problem with the laser is, at least the one I have, it's 100 watts, which is I would say of all the makers in this space, nobody probably has more than a 100-watt laser. So that's probably the most powerful thing that you're gonna find in the golf space. Even with 100 watts, it probably takes me, and I can actually show you, 16 passes on that design to get it to a decent enough depth where there's enough contrast for me to drop paint or to drop in a chemical to patina it. When I say 16 passes, there's also a crosshatch, so you double it. So what that means is it's gonna go 16 times this way and then 16 times in the opposite hatchway. So it's actually 32 passes to get to a depth, which I don't know, 0.01 inches maybe? We're not going much deeper than that. But you can see the intricacy that you're getting there with that level of passes. Now you get some kerf on it, which is the burnt edges, which we can easily take off with the sandblaster. But the other part to think about here as well is I've kind of dialed in this laser over time, where if I set it up against this rail, it's pretty much center. However, if you were to take some calipers and measure this edge against that edge side, it's off. Because that right there is placed by me eyeballing it as center. So again, the advantage to the mill, you have a probe that'll find the exact center of this piece and make it centered. Me, I'm eyeballing it on a laser, and that's all you can do there. In terms of programming, like we talked about before, I throw my jump drive into this computer, I upload that design. I need to figure out a formula in terms of how I want to get to the depth that I want to get to. And then I hit this mark button right here, which is the equivalent of the green start button on the mill. So I don't think it's much different, but I do get a whole level of intricacy more on this. But I'll tell you this, the engraving itself for this marker here takes about 15 minutes to engrave that with 32 passes. If I were to do something similar on a mill, it's one pass and you're probably clearing it out in about 3 minutes on the Haas. So the laser takes a whole lot longer, but you get a whole lot more intricacy. You might think 15 minutes might not be a lot of time to make a piece, but if I take that times 50, and then I gotta do something on the other side, we're talking about at least 2 or 3 days of lasering to get them all done. If I were to do that on the mill, I can probably do 50 pieces in probably about 3 hours. So lasering takes longer as well, especially if you want to laser engrave at depth. It's a very, very technical explanation on why you'd use a mill versus a laser. Benefits, pros, cons, and I could probably even spend another hour or two talking about it, but that might be enough for you guys. Hopefully you guys found this interesting. If not, let me know and I won't do that again. See ya.